Right, so we have another question on the board. We are still on the concept of gravitational field, and the question says the force of attraction between 2 point masses is 10 raised to power minus 4 Newton. The force of attraction between 2 point masses is 10 raised to power minus 4 Newton when the distance between them is 0.18 meter. Okay, so we take note of that. Force of attraction between the 2 point masses is 10 raised to power minus 4. Say that F is equals to 10 raised to power minus 4 Newton. And it says when the distance between them is 0.18 meter. Okay, so the distance between them, arrow, is equals to 0.18 meter. Alright, so the 2 point masses are M1 and M2. 2 point masses are M1 and then M2. Okay, alright, so we are then told for this first scenario now, you say F is equals to G M1 M2 over R square. Alright, okay, G M1 M2 over R square. Now the value of force here is 10. We are making use of Newton's law of universal gravitation. Don't forget that. This is Newton's law. Newton's law of universal gravitation. Newton's law of universal gravitation. Okay. Okay, so we have this. This is Newton's law of universal gravitation, and then we have the value of F as 10 raised to power minus 4. So this is 10 raised to power minus 4 is equals to G. The gravitational constant is 6.67, though we know that, so let's just leave it as G. We are going to make G the subject of formula times M1 M2, all right, divided by arrow is given to us as 0.18, all raised to power of 2. So if I square this, if I take the square of 0.18, I'll be having, okay, so I'll be having G M1 M2 over 0.0324. Okay, that's when I square 0.18. When I take the square of this, I'll have 0.0324. Right, this is equals to 10 raised to power minus 4. I'm making G the subject of formula. We could then cross multiply. I have G M1 M2 equals to 0.0324 multiplied by 10 raised to power minus 4. Okay, this is 10 raised to power minus 4. So if I multiply that now, well, I'll be having 3.24 times 10 raised to power minus 6. Okay, equals to G M1 M2. Alright, it's equals to this. So G M1 M2 is equals to 3.24 exponent minus 6. And the value of G alone, if I divide by M1 M2, this is G M1 M2 divided by M1 M2 is equals to 3.24 times 10 raised to power minus 6 divided by M1 M2. Okay, so this, we eliminate this. I'll have that G is equals to 3.24 times 10 raised to power minus 6 over M1 M2. So I'm having that G equals to 3.24 times 10 raised to power minus 6 over M1 M2. Okay, of which I can call this one my equation 1. Then I continue. It goes on to say, if the distance is reduced to 0.06. Now in the second case, they say we should find the force. We should calculate the force. That is, the second force is F2. When the distance R2 is equal to 0.06, the distance is reduced to 0.06. Actually, the initial distance was 0.18 in the first scenario. In the first was 10 to the minus 4, the distance was 0.18 meter. And the second scenario, you find out that the distance reduces to 0.06 meter and we're asked to calculate the value of the force. Alright, now you go back again to the formula. The formula is stated as F2 will be equals to G M1 M2 over R2 square. Okay, so this is the force we are looking for, and the distance was given to us as 0.06. So this now changes. This implies that F2 will be equals to G M1 M2 over R2 is 0.06 all raised to the power of 2. Okay, why? Because there is a power 2 there, all raised to the power 2. So this is the power 2. Now if you check your calculator, 0.06 raised to the power 2, you'll be having, okay, so you'll be having, this is F2 equals to GM1 M2 over 3.6 times 10 raised to the power minus 3. Okay, that is when you square this. You'll be having something like 0.0036123. 3.6 times 10 raised to the power minus 3 rather. Okay, that's when you take the square of this, and then you continue. We can call this one equation 2 rather. Now it says substitute equation 1 into equation 2. So in place of this G, which is the gravitational constant, in place of my gravitational constant, I'll be writing this 3.24 exponent minus 6 divided by M1 M2. Okay, so I'll now substitute it, and I'll have F2 equal to, place of G I have 3.24 times 10 raised to the power minus 6 divided by M1 M2 times M1 M2, okay, over 3.6 times 10 raised to the power minus 3. Okay, so you see that this one cancel out this one. Okay, and you'll be having, okay, so when these two eliminate, this will cancel out this, and I'll have that F2, my force F2 will be equals to 3.24 exponent minus 6 rather, exponent minus 6 divided by 3.6 exponent minus 3. Okay, alright, so if I divide it now, I'll be having that F2 is equals to 9 exponent minus 4 in newtons. This is the value of the force. Okay, so when I divide this, 3.24 exponent minus 6 divided by 3.6 exponent minus 3. So when I divide these two, I'll have 9 exponent minus 4. By dividing this, I'll have 9 exponent minus 4 as my force. So that's the second force. So you see that the magnitude of the force of attraction when the distance is reduced to 0.06 is 9 exponent minus 4. This is the final answer. Okay, 9 times 10 to the power minus 4 Newton. Alright. Okay, so I'll quickly explain this. They say the force of attraction between 2 point masses is 10 raised to the power minus 4 Newton. Okay, now you see that we stated that as 10 raised to the power minus 4 Newton when the distance between them is 0.18. The distance r is 0.18 meter. So say the 2 point masses are M1 and M2. Using the Newton's law of universal gravitation, we have F equals to G M1 M2 over R square. The value of F is 10 raised to the power minus 4 Newton. You put it here. Then the value of R is 0.18. Place it there. Raised to the power of 2. 0.18 raised to the power of 2. 0.0324. Alright. Then if I then cross multiply 10 raised to the power minus 4 times 0.0324 gives me 3.24 exponent minus 6. That is 3.24 times 10 raised to the power minus 6. Okay, so I'll divide both sides by M1 M2. This will cancel out this, so G will be equals to 3.24 times 10 raised to the power minus 6 divided by M1 M2. So I've got to my gravitational constant. The gravitational constant is G equals to that 3.24 times 10 raised to the power minus 6 over m1 m2. I made capital G the Solator formula. Call that equation 1. Now, in the second case, we are told that if the distance is reduced to 0.06 meter, if the distance is reduced to 0.06 meter, calculate the force. So we are asked to find the magnitude of the force of attraction when the distance is reduced to 0.06 meter. You still go back again to Newton's law of universal gravitation. It says F2 is equals to G m1 m2 over r2 square. r2 is 0.06. Okay. Now raise it to the power of 2, you'll be having 3.6 times 10 raised to the power minus 3. Okay. Now remember I told you that we got the value of G as this. Now you substitute equation 1 into equation 2. So in place of G here, I'll be writing the whole of this. Okay. So this now will be F2 equals to 3.24 exponent minus 6 all over m1 m2 multiplied by m1 m2. That is multiplied by this. So m1 m2 we cancel m1 m2 all over 3.6 exponent minus 3. So you are left with this 3.24 exponent minus 6 and 3.6 exponent minus 3. So when I divide this by this, I'll be having, this is it, I will divide it and I have 9 exponent minus 4 Newton.